Hi, everyone. Welcome to this Copernicus Marine Service workshop dedicated to the Baltic Sea region. I'm happy to see that you're so numerous to attend today. So you're here for 2 half days plus a debriefing session workshop in which you will be able to discover the Copernicus Marine Service. So this training is dedicated to beginners, but if you are yet a user or if you already know about us, there will be something to learn for you, especially tomorrow during the practical session. But before digging into technical consideration, let me just introduce myself. So I'm Aurélien Mur, I'm training officer at Mercator Ocean International, that is in charge of the Copernicus Marine Service. And I'll be one of your 2 moderators for today and tomorrow. And Ergan, good morning.
Hi, good morning, Aurélien. Good morning, everyone. Thank you for being here today. My name is Ergan Fouché. I'll be hosting this workshop with Aurélien today. And I'm an oceanographic engineer from Noveltis.
Thank you. So, a few technical details before starting the presentation. We have provided you a single access point for the training. This is a Padlet platform. Ergan will send you the link in the Zoom chat right now. Feel free to open it directly. So there you will find the e-learning material, the participant manual, the replays of the session after today and after tomorrow. And you will also find there the PDFs of the presentation. And it will be available for months. So if you have one thing to remember from this workshop, it's the Padlet so that you can work on your own after the sessions. So during this session or after, please pin your location in the Padlet so that we have an idea of where you come from. So most of the interaction between the lecturers and the participant will be at the end of the session. So we will take a few questions live, but all your questions will be answered and available on the Padlet. We will send it to the expert that will answer after, even if it's not taken live. We have a tool for the questions also. So please do not use the chat of the Zoom session for the question to the lecturers. We have a Slido, so Ergan will also send you the link in the Padlet, in the chat, sorry. And on Slido, you can vote for the questions if you want them to be answered live. The chat on Zoom is only for small talk. And Ergan will just give you a few words about what will happen today.
So we are having the welcome and agenda presentation right now. Just after this presentation, Aurélien is going to introduce you to the Copernicus Marine Service. Then we will have a presentation, well, some presentations of the products that are available in the Copernicus Marine Service catalog. So the data experts are going to present you the satellite observation products, the in-situ products, and also the model products that cover the Baltic Sea region. Then we're going to have some user testimonies, especially one about the marine.meteo.lv, which is a Latvian data portal for marine data. Then we're going to have a presentation of the user corner and the e-learning material that are available and that have been prepared for this workshop. And finally, we'll have the presentation of the workshop day 2, so the session that's going to take place tomorrow. And after the workshop, so about at 11, if you're available, you can stay, and we're going to have some free talks with the experts. All the experts that have presented their activities during the workshop will stay with us, and you'll be able to speak to them and ask your questions.
Thank you, Ergan. So I'll start with the general presentation of the Copernicus Marine Service, and I advise you to stay at the end. I think it's a good time to have a direct talk with the experts. So 8 years ago, the European Union launched the Copernicus program. The objective of this program was to develop and implement an operational Earth observation program for Europe. So based on in-situ and satellite measures, the 6 services that you see on the screen give a free and open access to Earth observation data. And for the Marine Service, Mercator Ocean International manages a network of producers. So we have observation data providers, monitoring and forecasting centers. So there is the Copernicus Marine Service provides data for the blue ocean. So the blue ocean is physical state of the ocean, for the white ocean, for the sea ice parameters, and for the green ocean for biogeochemical parameters. So the key things to have in mind about Copernicus Marine Service are that this is a single access point via the web portal marine.copernicus.eu that you see here on the screen. With a simple registration, you can access the free catalog of products, and all the data are scientifically validated and qualified. And they are also harmonized, all on the NetCDF format. And our approach is really user-driven, so the evolution of the service takes into account the user requirements. So for the ocean products, the core of the Copernicus Marine Service, it offers a large range of data. It can come from different sources, model, in-situ, satellite, as you will see with the following presentations. It covers 7 areas. One of them is the Baltic Sea. And there is different time scales and different rates of updates. And with all these sources, the data are made to fit the user needs. But Copernicus Marine Service is not just a data provider, it's more. There is, for example, the Ocean State Report that provides each year a comprehensive and state-of-the-art report on the current state, natural variation, and ongoing changes in the ocean. You will also find on our website the ocean monitoring indicators that are key variables used to track the vital health sign of the ocean. And we also provide some visualization tool that allows visitors at different user levels to dive into our digital ocean and explore it. There is 12 blue markets that are grouped by the 3 pillars of the United Nations Sustainable Development Goals. There is environment, society, and economy. And you can find on our web portal specific content which give you an overview of the usefulness of our data on every blue market. The Copernicus Marine Service provides a tailored user experience with a training session, e-learning material, and strong user support. Cedric will tell you more about it at the end of the session. For example, for those interested in artificial intelligence and Earth observation, you have the AI for EO MOOC on the Wikio platform, and Copernicus Marine Service is a partner for this MOOC that is a super tool. So please get in touch with us and with the community via our social media networks to be informed of our new events, the publication, and the product releases. And if you join the community, for example, on Twitter, we are around 10,000, and all the tutorial videos and the replays of our events are available on our YouTube channel. So that's all for me. Thanks. And we're going to start with the... Thanks. And we'll start with the presentations.
Okay, so thank you. Now that we have learned about the Copernicus Marine Service, we can begin to dive into the products. And we're starting with our first data expert, who is Juha Kauvonen. He's going to present us some satellite observation products, sea ice and sea surface temperature. Hi, Juha, can you share your screen?
Okay, so you can see it now, hopefully, and I can start. So I'm Juha Kauvonen from the Finnish Meteorological Institute, and I'm going to give a short introduction to sea surface temperature and sea ice observation products. Okay, first we have this CI Thematic Assembly Center, which is coordinated by Met Norway in Norway, and there are many partners, and FMI is responsible of the Baltic Sea products. In this, there are also partners from Denmark and Norway, France, and also from UK. And in the Sea Surface Temperature Thematic Assembly Center, it's coordinated by Consiglio Nazionale delle Ricerche Italiane, and there are also DMI involved, and DMI is Danish Meteorological Institute, is responsible of the Baltic Sea surface temperature products. Okay, I have added here a text because in this CI stack we have problems with this reduced amount of SAR data, because Sentinel-1B, there was this anomaly in December 2021, and it's been offline after that, and that's why we have tried to find some complementary data from Expand SAR, but of course the automated products are still under construction for the Expand data, because we have relied on C-band data. Now we have C-band data only from Sentinel-1A and some from Canadian radar satellites. Okay, about the sea surface temperature products, there are three products. There is this 0.02 degree resolution sea surface temperature from nighttime data from multiple satellites, and then there is this 0.03 degree product using also many input sources, infrared radiometers, and then there is a time series product which is updated biannually. And well, okay, the production they at the DMI they use this optimal interpolation to get the products, and here is the operational production chain described. You can probably ask more on the details from those DMI. I can provide you their email addresses, and it's been validated, and the validation results look quite good. Here are some examples of the validation, and here is also about this time series product, which starts from 1982, I think, and it's to estimate the ocean monitoring indicators, and here we can see the okay, it's not so large the axis numbers there, but this shows the trend from 1993 to 2020, and also the temperature trends is shown on the right hand side, so we can see warming there. There will be also some new products in this year. Okay, here is then the FMI CI's data processing chain. We have inputs from many SAR satellites. There are Expand data from Cosmos Skymet, TerraSAR-X, and this year we have also started receiving ICEYE X-band SAR data. But the main data sources are these C-band SAR instruments, which have been mainly from the Sentinel-1A and Sentinel-1B, but now the Sentinel-1B is off, and we have to rely more and more on RadarSat-2, which is an old instrument and may not be available a long time anymore. We have also this RadarSat Constellation mission from Canadian, but we have not received much data over the Baltic, at least not yet. Okay, then the data received in multiple ground stations, including our own Sodankylä ground station, and then we get it to FMI by FTP pool, and then we deliver it to Met Norway, both ice charts, which are based on the visual ice analysis, and those automated products. And the products are also delivered to this so-called IBNet, which is connected to the Finnish and Swedish icebreakers, and they need the sea ice data to aid the winter navigation in the Baltic. Okay, here are the short list of the sea ice product categories. There is this 011, 004, which are the ice chart products. There is an ice concentration grid, 1 kilometer resolution daily, based on multiple instruments. The main data source are the SAR imagery, but there are also other imagery for microwave radiometers and visual and infrared data, and also the ice thickness has the same kind of grid size and produced daily, and it's also based on observations on board ships, mainly the icebreakers and also coastal observations. Then there are these automated products based on SAR data and microwave radiometer is 011 category. We have sea ice thickness, which is in 500 meter resolution. It's produced after receiving a SAR image in 4 hours, and then we have also a mosaic product of the ice thickness, which is produced twice daily. And then we have this sea ice concentration product, which is also a daily mosaic. These are all in 500 meter resolution. Then we have also the sea ice drift, which is actually a little bit lower resolution of 800 meters, but it's based on SAR image pairs, which are overlapping, and the sea ice drift is estimated based on the drift recognized in these images. And we also now have another sea ice thickness product based on this Sentinel-1 interference widespread mode data now. And then we also have this ocean monitoring indicator product, that is sea ice concentration, extent, and classification time series. And it's the time series starts from the winter 1980-81, and it's weekly data until the winter 2005-2006, and from the 2006 winter 2006-2007 it's daily data, and it will be updated after each ice season. So the next update will be in June 2022. Okay, then what we have under development, we are trying to adapt to the new instruments, especially to this X-band SAR data, because we have now less C-band SAR data, and also to improve the algorithms and develop new products degree of ice deformation is very important parameter for navigation, because in the ridged areas or the deformed areas, navigation is very difficult, and an icebreaker aid is required. Okay, here are just the numbers of the product for the last season 2020-2021. So there are these daily products which are about 30 products per month, and then there are these products based on individual SAR images or SAR frames or SAR frame pairs, and there are of course much more of them. Okay, just examples of these are ice chart products. These are for the 7th of March this winter. The sea ice concentration and sea ice thickness products based on the ice charts in 1 kilometer resolution. Then the products based on the automated analysis. Actually, these are the products for the next day, 8th of March. The ice concentration on the left and ice thickness on the right. It can be seen that the ice thickness of the automated ice thickness gives thicker ice than the ice chart, but this may be due to the fact that the ice chart from the ice chart we give the average thickness. And also we have this new product based on this IW mode Sentinel-1 SAR data. It gives a little bit thinner ice than this model based on this HH wide sweat mode data. Then an example of the ice drift. This is kind of a little bit old, but it shows the ice motion in a couple of days period. We have the first image and the second. You can see that the ice is drifting to about the southwestern direction, and here is the corresponding vector field estimated from the SAR image. Okay, then there is some who can kind of benefit from this ice data. We have navigation, ice services. We hope that modelers would use more this data assimilation and their validation, of course, in research, in offshore and coastal activities, construction, also the general public. We have also launched this BALFI service, which is the sea ice, land fast ice service, which means that these are the areas where people can move around. For example, winter fishing, skiing, ski doing, or anything. And we provide.
I'm sorry to interrupt. I see that you may have something left to tell us. If you can conclude in 1 or 2 minutes so that we do not overstep too much on the other presentation.
Yeah, no problem. I don't have much more slides anymore. Okay, then a few words about the evaluation or validation still. The problem with sea ice is, of course, that we have only restricted amount of observation data, because the observations are very, very difficult and expensive to perform. So we use, for example, other Earth observation products to cross-validate our products. We have some icebreaker measurements of sea ice thickness, but they are of course very local and very few, maybe a few hundreds of those measurements, point measurements during one winter. Then for the ice drift, we have drifter buoys. And okay, we also have some occasional campaigns, but not very often. Then we have this sea ice mass balance buoys measuring the ice thickness, but this COVID pandemic has restricted this SIMBA deployment, unfortunately. And of course, for Copernicus Marine Service, we provide these seasonal data quality reports, and the evaluation results are the evaluation results are well put there. Well, okay, I guess that's what I had to say this time. Thank you.
Thank you very much, Juha. So we have some questions already on the Slido, some really interesting questions. Some of them are linked with also in-situ data. Just take 30 seconds to tell you that at the end there will be a breakout room where you will be able to interact directly with the experts. So as we may run late, I will go on with the next presentation, but your question will be answered at the end. So thank you, Juha. If you can just finish your slide presentation. Okay, thank you very much. So I will share mine. Okay, so we'll continue with Kirsten Stelzer from Brockman Consult. She's an expert on satellite observation products, and especially she's the Copernicus High Resolution Ocean Color Tag Service Manager. And she will give you a presentation about ocean color. Kirsten, if you want to share your screen.
Yes, I will share my screen.
Thank you.
I hope you see it.
Yes, great, go on.
Yes, good morning, everybody. I would like to tell you something about the ocean color products that are derived from satellite data. And this is a presentation of a team of us. And this team is for the ocean color tag, so also the OC tag is quite big. So we have several partners, and the partners are responsible for different kind of products. And we have in general, we have several lines which go in a near real-time service or in the multi-year service. And the different regions and the different kind of services are distributed among the CNR, which is leading also the OC tag, ACRI, PML, and Brockman Consult Arbin's service providers. And in general, if we talk about ocean color, we talk about reflectances, water-leaving reflectances, about chlorophyll concentration, turbidity, backscatter and absorption, or the attenuation coefficients. So those are the parameters we are providing in these different kind of products. And for the Baltic Sea, we have services that are near real time. So they are there the day after the acquisition, and we have multi-year lines which have long year time series. And so Baltic Sea is one of the regions that are served. And there are medium resolution products and there are high resolution products. Medium resolution products are based on OLG or on multi-sensor. The multi-sensor are the more longer time series because the other sensors that were before Sentinel-3 OLG provided data from the years before, but since 2016 there's also the OLG, and this provides products for the Baltic Sea using certain neural net approaches that provide us the parameters I just mentioned for the Baltic Sea. There is development on this algorithm side. So we have a bit of a combination of different algorithms since now, but there's a consolidation ongoing on the archive or on the catalog. And this will then ensure that we will have the same near real-time products that we have also for the multi-year products. So there's a bit of consolidation ongoing this year, which will be available end of 2020. as said, there are different time series and different sensors. So mainly Algae we are now building on for the medium resolution data, and Sentinel-2 we are building on for the high resolution 100-meter products, and I will come to those in a second. But looking into the time series, so we have this multi-year product which starts already late 90s. And from such nice time series, we can derive certain indicators. And what you see here is that we have an indicator for the spring bloom in the Baltic Sea. So the area that is covered by a bloom, defined with a certain threshold on the chlorophyll concentration for the different years. And we see where we have quite extended spring bloom and where we have smaller spring blooms in which years. And the second graph shows the occurrence of the summer bloom. So this is mainly cyanobacteria in the Baltic Sea. And if we have surface blooms, or if they are submerged, and or if there's something in between. So this can be derived from the optical satellite data and from these long time series in order to see the differences in between the years. If you want to go to the products, there's the catalog that has been already shown. And if you go for certain search criteria like color in the search and Baltic Sea, you retrieve 8 hits that provide you the different products that are there. So it's the chlorophyll concentration from algae, and the optical products from algae. And we also have differences in daily products or in aggregated products. For instance, for the high resolution products, we have the daily products, but also the monthly averages from 1 month, and all products are collected together to give a monthly average. You see here a difference between the medium resolution products and the high resolution products. The medium resolution products cover the whole Baltic Sea, and the high resolution cover 20 kilometers of the coastline for the coastal waters, because it's a coastal product. Then if you go to one of these products and want to know more about it, you see all the metadata, the time it's covering, the spatial resolution, the algorithm that are used. So to get a bit more information, this is the metadata. And then if you go to documentation, you also retrieve detailed description of the algorithm, of the validation results, and how the products are built. So those are very useful information that should be read when working with the products in order to understand how to use them, and where are the limits, where are the acid of these products. There's also a quick look on the products with the Lobelia viewer, and you can add layers and select them from the catalog. And if you have seen something that is really of interest for you, you can go to the download, and then you go back to the catalog and to FTP or to other ways of downloading the products. And what you see here is the medium resolution example for the chlorophyll concentration. And what you see here is the chlorophyll concentration for the high resolution, the 100-meter spatial resolution products based on Sentinel-2. And I would like to go a bit deeper into those products because I know them best. And so we have different parameters already mentioned. So the water linear reflectances, turbidity, suspended matter concentration, backscatter, and the chlorophyll concentration. And as you see, we have here these 20 kilometers stripe. This is the turbidity shown for 1 month, July 2020, monthly average. And if you zoom into such an area, you see that we have a different turbidity and more turbidity coming from the land side, and you see all these little islands that need to be masked out so that the product is not showing wrong results. We have to cover a lot of different ocean color, ocean colors, so very different kinds of water types, and therefore this algorithm is a merged algorithm that is derived from different algorithms we have in place, state of the art. So we have different atmospheric corrections that we combine 2 of them. We do a merging, and after the atmospheric correction, we do a water parameter retrieval, like the chlorophyll concentration and the turbidity. And also here we do a merging of different algorithms that are published and that are state of the art. And from this we get, you see here the very different coastal waters compared to the clear ones. In order to cover all of them, which are in one image, we use these different algorithms and do a merging of them. We also performed validation, and here with the ARNet OC stations in order to test our merged approach for the atmospheric correction. And you see here the relationship for different reflectances, different spectral bands from these high resolution coastal products. And for the turbidity and chlorophyll, we used a lot of in-situ data we found. You see here the different European seas, and here for the Baltic. And we used only the stations which are close to the coast, because our product is also close to the coast. And this is why we have a selection of in-situ data, and we compared then the turbidity and the chlorophyll concentration we retrieved with the in-situ data. And this is all documented in the documents I mentioned before. So for the high resolution coastal product, we have a coverage of the full European seas, and you see here part of the Baltic. They are provided in the near real time, so it's available the day after acquisition. And we have also gap-filled products and monthly average products. And yeah, if you work with these products or with the medium resolution products, we would be very excited to receive feedback and things you observe. And yeah, but for this, I would like to thank you to listen, and to my colleagues to contribute to this presentation. Thank you.
Thank you very much, Kerstin. So Kerstin will also be here at 11 in the breakout room, so that you will be able to ask your question. There is a lot of questions, thanks. You know that you have to know that they will be answered. If you cannot be there at 11, they will be answered in the Padlet. So let's continue with our presentations today. Okay, so the next speaker should have been Johanna Linders, but she couldn't make it today. She is a physical oceanographer and expert of in-situ observation products. But her presentation will be given by Simon Boitard from Noveltis. So Simon, the floor is yours.
Hi, thank you, Aurélien. So I'm going to share my screen. Okay. You can see it now? Yes?
Yes.
Okay. So hi everyone, my name is Simon Boitard, and I work as a remote sensing engineer for Noveltis in Toulouse in France. So today I'm going to briefly introduce you to the in-situ component of the Copernicus Marine Service for the Baltic Sea region. So I'm doing this presentation on behalf of Johanna Linders, who's a physical oceanographer at the Swedish Meteorological and Hydrologic Institute in Sweden. So the slides are hers and I'm simply a messenger. So why is it important to have in-situ observations? So without sufficient observations, useful prediction will likely never be possible. The models will evolve and improve, but without data will be untestable, and observations not taken today are lost forever. So the ocean is a complex system to observe, and many processes are involved, be it input from different areas like atmosphere or rivers, or the evaporation, or the input of and output of carbon dioxide. So to observe this system and all the processes that are involved, a multi-platform approach is essential for observations. So the in-situ observation means are of several kinds. Research vessels are used, gliders, moorings, drifting buoys, high-frequency radars, and Argo floats. So the Copernicus Marine Monitoring leg for the Baltic Sea has an in-situ component, and this in-situ component ensures a consistent and reliable access to a range of in-situ data with the purpose of service prediction and validation of the delivered data. This in-situ component manages 7 regions, so the global region and 6 sub-regions, the Arctic, the Baltic, which is of interest for us today, Northwest Shelf, Iberian, Biscay and Ireland, Mediterranean and Black Sea. It also, and different entities are responsible for scientific expertise cross-cutting and the maintenance and evolution of the in-situ system. So the in-situ component of the Copernicus Marine Service has been fully operational since April 2015. The Copernicus Marine Service catalog constitutes the unique point of access to all available data. The products are openly and freely available. The in-situ component has a strong collaboration with EuroGOOS, SeaDataNet, and IMODNet. As previously mentioned, it has 7 components, so global and 6 regions. The data are distributed in a single data format, which is the NIT-CDF format, and the packaging method is based on scale factor and offset. There is a common FTP structure to access the products for all regions. The in-situ component has been carrying out a huge work to homogenize the variable names, the units, and the attributes and the field value in all the distributed products. All in-situ data have the same real-time quality check and quality flagging convention. And the products are distributed in 2 different timeliness, near real-time and reprocessing. So the in-situ component has 2 main objectives. The first one is to collect multi-source, multi-platform, heterogeneous data and perform consistent quality control and distribute the products in a common format in near real time, which means within 24 hours. So they distributed to the Copernicus Marine Services downstream users and modeling and forecasting centers for assimilation into their numerical ocean models. The second objective is to supply the modeling and forecasting centers and downstream users with reprocessed 25-50-year products in delayed mode. So in addition to the near real-time products, these delayed mode products are useful for model validation or assimilation in ocean reanalysis and climate studies. So the near real-time products are updated 4 times per day and are delivered on a more frequent basis. They are distributed in at a global and regional scale, and all variables are available, which means temperature and salinity, wave, current components, biogeochemical data, sea level, high frequency radar, and carbon data. The reprocessed products, which are further validated and assessed, are distributed at a global scale, but only some variables are available. So the temperature and salinity since 2015, the UV currents from drifters and from high frequency radar, the waves are available since 2018, the biogeochemical data, so oxygen concentration and chlorophyll A since 2018, and the carbon data since April 2019. There are a suite of fundamental documents that are associated with each product. If you're not familiar with In-situ data, we highly recommend you to have a look at the product user manual and the quality information document. Currently, there are more than 7,000 platforms that are active in real time. More than 58,000 platforms are integrated. So the access to the In-situ product is easy, and only a free registration is needed. So as previously mentioned, you can access all In-situ products from the Copernicus Marine Service Data Catalog. So once on this catalog, if you search for the Baltic area, you will find the Baltic Sea In-situ near real-time observations, which you can see on the right of my screen here. Then regarding the In-situ data access, you can have access to In-situ products through the FTP protocol. The product identifier is the one that is displayed at the top left of my screen here. And here is an overview of the FTP structure. So here, if you want to access the In-situ products from the Copernicus Marine Service web portal, you just hit access data and then ocean In-situ. You will end up on the following website, the marineinstitute.eu web portal, where you can access the data. So from this web portal, you will find all the documentation that you need, such as the system requirement document, the product user manual, the parameters lists, the quality control procedures, and some useful code. For example, some code, some example script to select and download data files from the FTP. On the monitoring button, you will be able to check key performance indicators. So for example, the delay of arrival, the number of platforms, the data quality, the data providers, and the data files. So this is the dashboard from the marineinstitute.eu website. So if you're interested in manipulating, working, and processing some In-situ data, we highly advise you to have a look at this dashboard and play around with the different filters and the different options that are available there to check the data and filter out the data. For example, so on the same web portal, from the left bar, the little button over there, you'll be able to set up some filters on the in-situ products you wish to search for, and for example, to select the geographical area you're interested in. So for example, the Baltic Sea, the time frame you're interested in. So for example, the last 30 days or the last 5 years, or since the beginning of the measurements. Then you'll be able to select the different instruments that are available. So for example, in our case, in the case of this example, the tide gauges, then you're able to check the parameters that are available, where the in-situ instrument is located, whether it is active or not. Then you can check the data or download the data. For this, you just need your Copernicus Marine Service credentials, and then you can download the NetCDF files and check the time series of the measurements. So yes, this is it for the in-situ component of the Copernicus Marine Service for the Baltic Sea. Thank you for your attention. And if you have questions, you can ask them on Slido, and Johanna will be there to reply any questions during the debriefing session on April 8th. Thank you.
Thank you very much, Simon, for this presentation. As he said, Johanna will be there for the debriefing session on April 8th. So if you have any question to ask her, do not hesitate to register to this debriefing session. And we are now giving the floor to our last data producer, Vibeke Hoes, from the Danish Meteorological Institute, and she is going to present us the model products. Hi, Vibeke, can you share your screen? We can't hear you, sorry. You're on mute on Zoom.
Can you hear me now?
Yes, thank you.
Okay, there was a box coming up that you were not allowing. I don't know. Okay, but good morning, everybody, and thanks for giving the floor to me. I will shortly introduce the model product we have for the Baltic Sea. I'll just continue. So, taking an overall picture of what we are serving into the Copernicus Marine Service, we have 3 forecast products, and we have 3 what we call multi-year products, or reanalysis, or hindcast. They have many names. And then we have what we are calling ocean monitoring indicators. I don't think they have been mentioned before today, but that's some derived product that we are making to sort of give an indication of what can you actually use the core product for, to say we think those are some key indicators that say something important about the status for instance, for the Baltic Sea. So if we're taking the last one first, so the Baltic model team, we are responsible for making 7 of those indicators for the Baltic Sea. Some of them are based on observation and some of our own model products. But you could go in. I will not talk more about those today, but you can go in on the website if you're not already familiar with that and check them out. There are many different indicators. But going a little bit back to what we are producing, those forecast product or near real-time product, I have listed the name of them. So it's for the tree ocean, physical ocean, it's for the biogeochemical ocean, and it's for the wave conditions. And all our forecasts are updated twice per day with a new 6-day forecast. And they are also available about 2 years back in time compared to today. And so you can go back 2 years and look at the forecasts or at the hindcast of the forecast product. And then we are having those 2023 multi-year product. Again, it's for the physical and it's for the biogeochemical and it's for the wave. And they are all available back from 93 and until present year -1. And I will come a little bit back to all this product, of course. But who is the modeling contract owners with the Marine Service? We are a consortium, and we are 5 different Baltic Sea institutes. And I'm from the Danish Meteorological Institute, DMI, and we are leading this consortium. We're doing all the work together with BSH from Germany, FMI from Finland, and the Technical University of Tallinn from Estonia with the Marine System Institute there, and with SMHI from Sweden. And we have had this contract with Meteo for several years now. And back in time, we decided that we would like to join our forces and provide the modeling service for the Baltic Sea within the Marine Service for Copernicus. And all of us have a long tradition of doing oceanographic activities in the Baltic Sea, and we all have national obligations for the Baltic Sea, and some of us also for the North Sea. But this is who we are, and we have been working together for many years now within Copernicus Marine Service. So, coming back to the forecast product. As I said, we are doing a 6-day forecast twice per day. So it's updated around noon and just before midnight every day. We are forcing the system with the atmospheric forcing combined of first the high resolution weather data that we have for the Scandinavian area. So that's the Harmony system. And the resolution is 2.5 kilometers. And after the first 2.5 days, we are shifting to use ECMWF high resolution or the deterministic model system with 9 kilometers. So that's for the last couple of days. I have listed here the system that we are running. We are running the ocean and biogeochemical system in an online coupled way, one way. So Nemo is providing input to the ARGAM code that we are running. And let's just go through how the setup is. We are, for the time being, running with Nemo version 4.0, and we are using the ARGAM code for the biogeochemical. It's a system, if you're not aware of this, developed by IOW in Germany, and it's dedicated for the Baltic Sea. As I said, we run it as an online one-way copy system, and further we are also reading in the ocean is also coupled, offline coupled or forced by Stokes-Drift from WAM. And we are also doing data simulation we are taking satellite SST product every midnight and assimilating that into Nemo. We are forcing the system by river data and nutrient loading from SMHI's EHYPE forecast dataset. And for the open boundaries that we have in the system in the North Sea, we are using data from the Northwest Shelf service within Copernicus Marine Service. For the Nemo and for ARGAM, we are still using climatology data at the open boundaries. Further, the biogeochemical system is also forced by atmospheric deposition, and we're using the EMEP dataset. So for the wave, we are using WAM 4.6.2. That's the latest version we are running, and we are coupling it or forcing it with data from Nemo with surface current and ice concentration. The product grid we have in the catalog is at the same size as the native model resolution, and that's 1 nautical mile. A little bit more about the physical and biogeochemical forecast product. You can see here the product area that we are providing into the catalog. So we are cutting it at the 9° east, but we are running the model with the whole North Sea to have a better simulation into the Baltic Sea. It's set up with 56 vertical levels, and we are providing different data set for all the product. We are providing hourly instantaneously data set with all the parameters that are listed in the 2 boxes. Then we're also providing a daily mean for those of you that would like to have a quick look at that, and also a monthly mean. And the daily mean and the monthly mean are just post-processed data set of the hourly instantaneously. Then further for NEMO, we're also providing 15 minutes instantaneously data for the sea level and also for the surface current. And for the biogeochemical product, we are also providing daily accumulated values for the net primary production. Yeah, and you can see the parameters that we are providing, and that's evolving all the time, but this is what's in the catalog for the time being. And as I said, a new forecast is available twice per day, and it's around midnight or noon and just before midnight, depending on where you are, in which time zone. For the wave, it's the same product area and it's the same grid points we are providing. And the parameters for the wave are the wave height, the wave periods, and the direction. And for the wind waves, the swell, and the total wave field. And then we have the Stokes drift. We provide that too. Yes. This is the immediate update plans we have for later this year, and that will be in November. We will add some new variables to the product we are providing. For the physical, it will be from NEMO, it will be the vertical velocity. We have never provided that before, but that will be included. And for the biogeochemical product, it's a lot of new parameters that we will include. I think there are 6 new parameters. Phytoplankton, zooplankton, silicate, the iron, and the light attenuation, and then dissolved inorganic carbon. And also for November, and maybe I should say that we are aiming at upgrading or updating all the system behind the product once per year. And for NEMO, for this year, we will add on more data to be assimilated into the system. So we will include temperature and salinity profile and hopefully get an improved quality of the NEMO product. For the ERGOM system, we are working very hard for the time being to correct the bug we have. And hopefully we'll manage to have that included in this upgrade later this year. So we are aware that we probably have a bug in the coupling interface between NEMO and ERGOM. And that resulted in the strange behavior when we were running a long simulation. So you have to be aware of this if you are looking into our ERGOM or biogeochemical products for the time being, the forecast product. We see an unrealistic trend in the nitrate. We are working very hard to fix this. And we think it's the coupling, it's the time schemes that are not fitting together. We hope, and then we can have this corrected. And for WAM this year, we will enhance the forcing from NEMO and include the sea level data. And then we potentially will increase the forecast length. We will decide that later this year if we will do this year or we will postpone it for next year. But else we'll extend it from 6 days to 10 days. And we are certainly interested in getting feedback from users of the product if this is urgent for any of you. So for the multi-year product, I will go quickly through them. If we start with the wave, the product number are listed here. And it's the same, based on the same system as we are running for the time being for the real-time production. And as I said, we have data back from 93 and until December last year. So it's December 2020 for the time being. It's the same product, domain and resolution with 1 nautical mile. The atmospheric forcing is done with ERA 5 reanalysis, and the ice forcing is from SMHI, FMI ice chart. And the wave spectra at the open boundary are from ECMWF model data. And the update of this multi-year product is done so far yearly, and that ensures that there's always an overlap between the near real-time archive and the Hindcast product archive. So you shouldn't have any data gap between the two product types. For the physical and biogeochemical, it's a slightly other system we are using for this one. It has been in the catalog since 2018. So in the Copernicus Marine Service, that's a long time period. But we are working on upgrading this, but that will be for next year. So the product that's in the catalog for the time being is based on Nemo coupled with Scopy, that is a Swedish developed biogeochemical system. And the resolution is a little bit coarser. It's a 2 nautical mile, but again, the product is served as a native model production. Yeah, and the update frequency is the same, so we are continuing extending this in time. Yes, and you can see the technical information about the forcing data set here. But basically, it's still the same structure that we are running the forecasting data set with. And the plan for next year is to upgrade this to have a system that is as close as possible to what we're using for the forecast system, both for our internal workflow that we only are working on one system and we're using that for both the forecast and the Hindcast production, but also from a user point of view, of course, that it's the same system that you are comparing when going back in time and looking at the present forecast. So for next year, we will upgrade the reanalysis product to the Nemo version 4 coupled with Ergon. Yes, then I'll just mention that the additional information, some of the other presenters have also mentioned this. So you can read about all the products in those product user manual and also in the quality information document. And further to this, all model products have what we call static files. For all products, we have a mass and bathymetry information listed there. And for the physical and biogeochemical or the 3D product, we have 3D coordinate information also. And for the physical, we have what we call mean dynamic topography. And for us, it's the mean sea level anomaly relative to the model 0. Yes. This is my last slide. I'll just say that marine services are course user driven. So it's very important that we get feedback from you, what you want, and then we can see if we can manage it, of course. But both positive and negative feedback to the existing product, but also ideas and wishes for future changes. And it's better if it goes through the central service at Mercator, and then they will guide all feedback you have to us, and we will take it into our account and plans. So thanks a lot.
Thank you very much, Vibeke. And Cédric will explain us just a moment later how to give the feedback thanks to the user support. So I'm just going to share a few questions in 2 or 3 minutes, and then we'll go on. So here are all the questions that has been asked. So there is a question maybe for Vibeke, but this one from Manuel Aguito will be answered in the extra session after 11. So here, please make all the answers in writings as well and kindly send us all by email. So this will be done not by email, but it will be available on the Padlet, so you will have access to it. So there is a question here from Cyril. Thanks a lot for the products and the work. Why is wind not available? So in fact, wind is not available, especially for Baltic, but as I will show you here, there is some wind products for the global ocean that covers also the Baltic Sea. So there is L4 and L3 satellite products for the wind. Okay, and then I wanted to take another question. Yeah, here, I downloaded the e-learning material. Can I open the file Baltic Beginner Overview in the Colab platform? I think it's better if you wait tomorrow. Tomorrow there will be a live session in which again we'll introduce you the e-learning material. So if you wait tomorrow, you will have a real training for this one. So that's all for the question. The other one will be answered in the extra session. So now we'll go on with our user testimonies. And the first is from Valtos Zezis, that is an oceanologist from the Latvian Environmental Geology and Meteorological Center. He will talk about the operational marine environment data portal marine.meteo.lv. Welcome, Valtos.
Oh,
yes, we can see your screen. So please
yes.
go on.
So I'm an oceanologist at the Latvian Met Office. Basically, it's a shorter version for the long name. Yeah, we've been a user of Copernicus Marine Service data for about 5 years. As you mentioned previously, the data has been available for about 7 years. So we've been also closely following the development of the catalog, and we're basically what you would call a downstream user of the data, and we're using it to provide the public services information on the conditions at the Baltic Sea. Yeah, basically some questions about why did we create this resource? I think it's pretty self-explanatory, and the graph that you see it depicts the user amount that we are receiving. The service has been operational for about 2 years now, almost exactly 2 years. The scale is logarithmic, but it shows how the users interact with our service during the year. Basically peaks at the summer, as you might expect. It's a public service, so people going out to the beaches, swimming, various water activities. For me personally, as someone who follows this data, the peaks in late February are also interesting, and I presume it's connected with the sea ice that's present in the Gulf of Riga. Yeah, so about the service that we provide, basically we take products from Copernicus Marine Service, do sort of filtering of the data sets available. As the colleagues previously mentioned, there are quite a lot of layers in each of the products that Copernicus Marine Service provides. We basically filter out the most commonly understandable data from the Copernicus service, from the two main catalogs, which is the wave catalog and the physical parameter catalog, and we implement them in our service. What we do additionally, we have access to atmospherical models as well, because we are a meteorological service, and we combine these data to also provide the atmospheric conditions, but only similarly to Copernicus Marine Service in more or less on broad terms. It's precipitation and wind that we also show to the people using our service. What we additionally do, since we're not a modeling center as maybe some of our colleagues are around the Baltics, we use the models that we have from our partners and community in Europe, but we do some let's call it basic recalculations of the models to do some new interesting data. For me personally, one of the most interesting data that we provide is it's a sea vessel icing risk. it's very useful for our forecasters and also for marine users to know the risks that can be associated with marine vessel icing, and such parameters are not so commonly found around the internet. And it's a relatively simple, straightforward calculation, but it does help our forecasters and users to assess the risk of marine conditions. Yeah, the portal basically it's available both in mobile and web environments, and offers all the functionality that you might be looking for. We're also steadily growing, so some functionalities are steadily being added on our service. But yeah, you can use it to see the layers in 2D across the Baltic Sea, do animation of the fields, and do some other additional functions on top of the data. For example, you can see we provide also very basic tracing of object drift estimates, which you can access through the surface current layer, and the user can point out any point, select any point on the layer, and do animation to see how an object might be traveling across the surface of the sea. The interesting part is that we also archived older forecasts, not very old forecasts, but basically 3 to 5 days of forecasts we keep it as an archive, so we can also provide the user a sort of an estimate of how the object might have been drifting up to the point that you've selected. So basically, you can see it's 3 days in the past and as much as the forecast goes in the future. We also provide the users in-situ measurements from our own stations on the coastline. The in-situ tag that was mentioned previously also shows 2 of our stations. The data is actually traveling somewhere around. I've been in touch with the in-situ tag people as well. So I know that the data is somewhere out there in FTP, but currently you can only see 2 stations from Latvia. Some other interesting functionalities, data converter that we provide. So basically marine users like to see data in knots, not in meters per second, but not always. So they can basically quickly switch between the 2 units. We provide also the official weather forecast for the marine search and rescue, which is available both in English and in Latvian, and might be also interesting for any leisure users like yachts and swimmers to get a whole bigger picture of what's going on in our territorial waters. This is for the Latvian territory. And sort of finalizing my presentation, the map you see depicts the users that we have received during these 2 years, and distributes them by the amount of users. So in red, the small tiny place you can see it's Latvia, but yeah, we also get users from the Baltics. I assume it's mostly leisure and everyday people that use our service, but you can see it, for me personally, it's quite inspiring to see that there are users from all around the globe, probably just examining our service and gaining insights. And yeah, and basically as for the progress, we've been following the Copernicus Marine Service almost since, I wouldn't say day 1, but since the Baltic products have been available. So I can applaud the people and the services that provide the data. We're very happy with it. We've following all the developments, and I'm very happy to hear that the 10-day forecasts are also on the table and coming soon. For us personally, for me personally, and our Met service, this allows basically access to the very high-tech data without actually needing to run the models ourselves. And then what we're interested, just to finish it up, to develop our products is climate is one topic that we're interested in very much. I've been looking through the data myself. And we're sort of figuring out how to manage it into our publicly available domain as well. And from my part, that's it. Very happy to answer any questions if there are some.
Thank you very much, Valters. It's very interesting to see how the Copernicus data are used, and your application is very interesting as well. So you'll be able to answer the questions in the extra session at 11 with all the experts. We were supposed to have a second user testimony. Lauri Niskanen from the Natural Resources Institute of Finland was supposed to show us a GIS approach to assess and identify suitable locations for offshore aquaculture. Unfortunately, Lauri couldn't make it today, but we hope he'll be there for the debriefing session on the 8th of April. So if you're interested in this subject, you can attend this debriefing session. And we are now giving the floor to Cedric Jordan from Mercator, who is going to share us the user corner and the e-learning material available.
So good morning, everybody. So just a moment. So I'm Cedric from the Copernicus Marine User Support. I don't know if you can see my screen.
Yes.
The website is okay? Right.
Yeah.
Yes, so you should see the main page of the of the website. So I'm going to give you an overview of the user corner page. And to reach this page, you have to follow. You can find it at the top right here of the page. So different sections are available. The first one is the first page to visit, is a getting started page. You will find a sum up of the offer and an operational path to know how to search data, visualize, download, be informed, learn, and if you have any question, how to contact the user support. So for each chapter, you will find useful links, useful video, useful links to the specific pages, etc. So it's important to check this page. Firstly, you will find a lot of useful links. So I'll come back to the user corner. The second section is as well very important because it concerns the Help Center. So in this Help Center, you will find more than 100 of articles. They are sorted by collection. To getting started, you can click on the title of the collection. You will find several articles, how to search, where is the product asset listed, etc. So you click on the title. All the article is available here. You just have to follow the information, the indications. You can as well search by keywords, for example, inform. If I want to be informed of operational events, what is an operational event? Is an incident, a maintenance, improvement, etc. So I click this one. So I will show you why this article is important just after the Help Center section. So here you have the timetable and you will find all the information to follow the operational events on the services and the products. This section, the third one, is user notification service. So in this one, you will find all the notification about the operationality. There are four different categories. So general, improvement, incident, and maintenance. So general, you will find general information, of course. Improvement, you will find information about the improvements, of course, but as well, for example, the information of the releases, on the releases. So if I click on the title here, I will find For example, it was for the release of last December. The next one will be in July. You will here there is a sum up of the release, and then two important documents, a notice. You will retrieve the information on the perimeter of the release, and no, this one, a transition document with the list of all the products with the impact on the specific product. So, for example, it's very. If I check for the Baltic, I take the first one, the model, physical model. I have information on the changes in the perimeter of the release. So these two documents are available. So you will find this information in the improvement section. For the incidents and maintenance, so the same principle, you will find the list of the in-progress incidents or fixed incidents. You click on the title, you have more detail. Here you can set different filters, the product source, the region, so Baltic, for example, parameter, etc. And then you can register, you can save your RSS feed. And in the article I showed you before, in this one, you will find information to retrieve this RSS feed to be automatically informed in case of future maintenance, etc. So, for example, in the free text area here, search, you can specify the name of your product. So if your product is impacted, you will be informed, or you can build the filter, the RSS feed you want. I come back to the user corner. The user learning services. Here you will find the list of the training workshops. For example, the next training. The e-learning materials. So in this section, you will find all the e-learning materials by level, by subject, by tool. And so if you stay at 11, you will meet Aurélien in the breakout room to have more information about this section, and he will as well explain, give you clues to browse the catalog efficiently. So I come back to the user corner. The product catalog. So forget this section; it will be removed soon because it's not really useful. So we decided to remove it. So e-learning material I'll show you just before. Product quality. In this specific dashboard, you will find generic information, the quality of the ocean parameters. So you can sort by color of the ocean, blue for physical, green for biological, and white about ice. You can as well sort by area. And so you will find useful information about the quality of the product. So I'll let you discover this page. It's more oriented scientific user. The product roadmap. In this page, you will find the medium-term improvements, modification. So for the moment, there is nothing about the July release, but it will be the case shortly. Up, user corner. Get inspired. In this section about use cases, you will find different applications using Copernicus Marine Service data. For example, the user testimony you showed before. You can sort by region, by country, by market. One of the blue market Aurélien presented before. You click on the card, and you have the description of the application, the product used, etc. So this page this section is interesting to have different examples of applications. The collaborative forum, there is a forum. It is currently ongoing. We are going to change it, but it is active, but you can use it. To register, you can follow this section. So it's important to know that to browse the catalog, to view products, to have you don't need to be registered, but to download data, it's you have to. So it's really easy and quickly. You have to give your first name, last name, email address, the country, the type of your organization, so the name and the website, and then blue markets. You accept policy and term and conditions, and you create your account. You will be receive automatically your credentials, and so you will be able to download data on the website. The FAQ, it's more a classic FAQ page with general questions. The service commitment and license, you will be all our engagement on about the services. You will find information on the user support, the time to answer, etc. And then to contact us, there are two different forms on the website. So this one, contact us. There is another one on the download page, which is report issue, to report a specific issue on the product or a service. So it's a classic form. You fill in the different fields, and you can upload the product file, and you submit, and you will reach the user support team. As well, on every page of the website, there is a chat option. So you click on the button. So it's in French because my brother is French, so this is why. The first section here, is directly connected to the help center. So you can put a keyword, and you will find a specific article. And in few minutes, you can as well, of course, contact us directly. Clicking on this, send us a message. We will answer in few minutes. And so you will meet Elena, you will meet Chloe, Alexi, or David. So a member of the team. You don't hesitate. They are really friendly. So don't hesitate. So for me, it's okay. So don't hesitate to meet Aurélien at 11 It's now 11, but just after in the breakout room. So many thanks for your attention.
Thank you very much, Cédric. Before splitting into the breakout rooms and speaking to the experts, I'm going to present you the agenda of tomorrow's session. So the workshop day 2 program. Can you see my screen?
Yes.
Okay, great. The session of tomorrow will be dedicated to practical sessions, so about Python, MyOceanViewer, and QGIS. Very briefly, the agenda of the session tomorrow. About the Jupyter notebooks, we're going to have first a beginner tutorial in which we will learn how to access the Copernicus Marine Service products. We're going to learn how to use netcdf files within Python and how to create basic plots and maps. So here, for example, we have a map of the sea surface temperature. We have some time series of the sea surface temperature as well, and some vertical profile of the temperature. We're also going to introduce you to the advanced notebook the advanced notebook, in which we monitor the eutrophication of the Baltic Sea. And the aim of this notebook is to assess the eutrophication and to locate the hypoxic regions. So again, we will have time series of the ocean parameters. We will locate the hypoxic regions and estimate the areas of the sea which suffer from hypoxia. So this is for Jupyter notebooks. You're also going to have a presentation of the MyOceanViewer. So here's a screen of the device. And finally, you're going to have some QGIS presentation. Again, a beginner exercise in which you will learn how to access the products again, how to install QGIS and its plugin NetCDF to GIS, which is used to use NetCDF files within QGIS. And finally, you will learn how to create maps and animations. These are examples of the plots you're going to make tomorrow with the QGIS beginner tutorial. And finally, you'll have a presentation of the advanced exercise, whose aim is monitoring the Baltic Sea ice coverage and drawing a safe ship route. So this is the same subject as Walter's presented before, drawing ship routes depending on the sea ice coverage. And so that's it for the subjects we will be covering tomorrow. Just to remember, it will start at 9 a.m. CET. And you will access the event with the same link as for today's session. Note again, also, sorry, that all the sessions are independent. If you're only interested in notebooks, you can attend only the session about notebooks, and the same for QGIS, etc. So that's it for my presentation.
Okay, so I'm just gonna briefly explain you how to join the breakout rooms. It is pretty simple. I'm gonna share my screen from here. No problem. Okay. So it's pretty simple. There is 4 breakout rooms. That's better like this. One for the model products, in which you will find Vibeke. One for the satellite products, in which you will find Yuval and Kirsten. One for the user testimony, where you will find Walters. And another one where you will be able to directly talk with us for your training needs. If you have anything in mind in a matter in which you will use the data and you don't know how, if you need some help, we will give you some e-learning material and we will give you some feedback about it. So it's pretty simple. Vincent in the main room will display how to be assigned to a room, and just feel free. And if you don't have time to stay, we'll see you tomorrow. I stop to share my screen. Vincent, if you want to put yours. So it's pretty simple. You have the breakout room button in the bottom of your screen, and you click on it and you go to the bottom because there is a lot of names, and you click on join on the breakout room that you're interested in. So I will move, but Vincent will stay here to give you some feedback if you have any problem. So for those who left, see you tomorrow. Thank you. And for those who stay, I'll be happy to discuss with you.
Hello, everybody. So, as Aurélien told you, we set up 4 breakout rooms, as you can see from the share screen. On your Zoom navigation bar, you can go to the room you want to go, and the experts are here to answer all your questions. So if you have difficulties to join a room, do not hesitate to tell me by chat. And they will assign you to a room. So Raphael, Katani, in which room you want to go? Okay. So once again, on your Zoom navigation bar, you should have a breakout room button, or on the 3 dots more breakout room, and you will be able to join a room. Raphael, I assign you to the satellite room. So if anyone encounters some problem to join a room, just tell me. Christina, I put you to the satellite room as well. Okay. Okay. So for the participants still in the main room, once again, use the chat if you have difficulties to join a breakout room. Or you can use on your Zoom navigation bar, you should have the breakout room icon where you should be able to join a room. So Yana Perez, okay, I assign you to the user testimonies room. Okay, there are still 40 people in the main room. So once again, for the last minutes of this session, we set up breakout rooms, as you can see from the slide on the shared screen. So you should have on your Zoom navigation bar a breakout room icon where you should be able to join the room of your choice, which are model product experts, satellite product experts, your training needs, and user testimonies. If there is some problem to go to a room, do not hesitate to warn me by the chat, and I will assign you to the room. Thank you, Antonio, for your comments, and see you tomorrow. If anyone needs help, do not hesitate to write me through the chat. So once again, for participants still in the main room, so we are on a breakout room session where you can ask your question to our marine experts. So we set up 4 breakout rooms. You can go and visit these breakout rooms thanks to your Zoom navigation bar, where you should have the breakout room icon. If it does not appear, it should be on the 3 dots more. You click on it and you have the 4 breakout room we set up for this end of session. And you should be able to join the room of your choice. Once again, if any participants have difficulties to join a room, do not hesitate to tell me which room you want to go by the chat. Thank you. Hello. So guys, we are in a breakout room session, so participants on the main room, so who can hear me at the moment, feel free to join the breakout room of your choice. To do so, you have on your Zoom navigation bar a breakout room icon, where you should be able to join the room of your choice. If any problem, do not hesitate to write me through the chat, please, and I will assign you to the room of your choice. Okay, for participants still in the main room, we have still few minutes for you to join the breakout room of your choice if you want to talk with some marine experts. So as you can see from the share screen, from the slide, we have model product experts room, we have a satellite product room, a room if you need to ask some question about your needs for the training, and rooms where you can chat with our user testimony. So to do so, you have your Zoom navigation bar where there is the breakout room icon. So click on it and join the room of your choice. Any difficulties, just write through the chat the room you want to go, and I will assign you to this room.
Cool.
Okay, Joris, I assign you to the model product expert room. If anyone needs help to join a room, do not hesitate to write me through the chat which room you want to join, and I will assign you to this room. So once again, you still have a few minutes if you want to talk to our marine experts by joining a breakout room we set up for the end of this session. So you can see from the shared screen that there is the model product experts room, the satellite product experts room, a room where you can ask questions about your needs concerning the training, and the rooms with our user testimony. So to do so, you have your Zoom navigation bar where you can click on the breakout room icon and join the room of your choice. Again, if you have some problem to join a room, do not hesitate to tell me by the chat and I will assign you to the room of your choice. Okay, Iris, I assign you to the satellite. Give me 1 second. Anyone needs help to join a room? Just tell me by chat which room you want to be assigned, and I will assign you to this room. So again, you are still 23 participants in the main room. For you, if you want to join a room, do not hesitate to use the breakout room icon on your Zoom navigation bar and join the room of your choice to talk with our marine experts. Any problem, just write through the chat, please. So Iman, which room you want to be assigned? Model product, satellite product, your training needs, or user testimonies? Your needs, no problem. Give me 1 second. Yeah, you are. If anyone needs help, do not hesitate to write me through the chat. I've been heard that the breakout room session is quite active with a lot of questions, so do not hesitate to join these breakout rooms. Again, for participants in the main room, if you have problem to join a breakout room, just tell me through the chat, please. Okay, I just send a message to all that the breakout room session will end in 2 minutes. Okay. Okay, the breakout room session will end in less than 1 minute.